All right, hey guys, let's start taking a look at your Unit 10 review. I'm just going to go through these step by step here. So number one, we've got three fractions. I need common denominators on all three fractions. So I think most of them are as factors as they can be, except for that first denominator. That's the difference of squares. So I'm going to factor my x squared minus 25, that guy, with the difference of squares. So it'll be an x plus 5 times x minus 5. Hopefully we are pretty familiar with the difference of squares. If you need to look at the formula sheet before the test, go ahead and do that and study these certain formulas for factoring. That was the only denominator I had to factor though. So the rest of these I'm going to write the way they are and see what they have in common. All right, so as of right now, x minus 5 is in these two fractions. It is not in the third fraction though, so I will multiply by the x minus 5 over x minus 5. All right, and then my x plus 5 is in the first fraction, but it's not on the other two, so I need to multiply this guy by an x plus 5, squeeze in there, over x plus 5, all right, and the last one as well. All right, and then my only factor I haven't looked at yet was the x plus 3. So the x plus 3 is only in that last fraction. I don't have x plus 3 in the first one or in the middle one. Let's see if I can squeeze this in. Okay. Well, there we go. So they all have these messy common denominators, but it's all the same. So I'm going to put it all into a single fraction. X plus 3, the x plus 5, and the x minus 5. All right, so that gives me in my first fraction, this is an x plus 3 times another x plus 3. Call it like x plus 3 squared. Minus, all right, in the middle one, it's got three factors all multiplied. All right, it's got an x plus 5, x minus 1, and x plus 3 all multiplied together. All right, it's going to get a little longer here. And then my last part here has a positive 3 multiplied by the x minus 5 and the x plus 5. Whew, okay. Now, I do believe that Big Ideas would take this the way it is. If you want to simplify, you will have to in the future. You'd have to do all the distributing and everything and simplify the numerator down. You can leave the denominator the way it is, but simplifying the numerator will take a little while. But I do think Big Ideas accepts this the way it is. Okay. So then on number 2, simplify the complex fraction, write your answer in factored form. So first things first, I want one fraction divided by one fraction. As of right now, I'm dividing by two separate fractions. I need to adjust this. So I'm going to multiply by x over x and x plus 1 over x plus 1. All right, so these now have common denominators, which means I can turn it into a single fraction. I'm going to leave the numerator, that top fraction, I'm going to leave that alone. All right, so on the bottom here, I get a 4 times x, so 4x, plus this guy, so plus the 6 times x plus 1, all over, and then the common denominator, each of them had an x times x plus 1, x times x plus 1. So this is over the x times x plus 1. All right, so this is kind of what I was going for. I'm going to simplify it down a little bit. I wanted one fraction divided by one fraction. Let's see about this fraction here, though. I think we can simplify a bit and doing a bunch of distributing. So let's see, not much I can do with the 4x, but this guy I can distribute my 6. I can get a 6x plus 6. And then I can do some more distributing here. I can get an x squared plus 1. Plus a 1x. I'll just call it x instead of a 1x. All right, and then now that I have it getting there, it's getting simplified, I'm going to leave that top fraction the way it is again, but what I'm dividing by, that guy, is going to turn into its reciprocal. So I'm going to multiply by, instead of the 4x plus 6x plus x in the numerator, that's going to go down here. And then instead of dividing by the x squared plus x, it is now in the numerator, the x squared plus x. All right, and I think I'm going to simplify this down a little bit. My 4x and 6x, those are like terms. I can go ahead and add those up for a 10x. All right. As far as simplifying goes, let's see. I'm going to distribute my 16. Actually, I don't even know if I need to do that, because if I factor out a 2 out of the 10 and the 6, I get a 5x plus 3. I think I can simplify this down a little bit. I can say, okay, 16 divided by 2 is 8. Okay. And again, let's look at these factors here for a sec. If those were still factored, if I had the x and the x plus 1 still like this, I would consider, does anything else divide out? But I don't think this x minus 2 doesn't match anything else in the numerator. The 5x plus 3 doesn't really match anything else in the numerator. I don't think it's going to divide out anything else. So I think I'm just going to leave it, excuse me, as the x squared plus x. I will distribute my 8 all the way across. So I get an 8x squared plus 8x. And in the denominator, I simplified the denominator down to the 5x plus 3. All right, so here is my simplified fraction. And then let's take a look here. Number 3, we're going to find the sum. This one is so much easier than number 1. Number 1 didn't really have any common denominators. Number 3 here already has common denominators, so that is pretty nice. I just need to add my numerators. So my 15 plus 5 gives me a 20. I've got 20 over 4x, and that can be simplified a little bit. I can do 20 divided by 4 is 5, so I can do a 5 over x, but that's kind of as good as it's going to get right there. And then number 4, find the least common multiple. So let's see here. What they have in common, it's a common multiple. They have currently a 2x in common, okay? The part that's not in common is that x minus 5, so I need to include the x minus 5. And I believe this is my least common multiple. I've used each of these factors at least once, only once actually. Alrighty, and then next one, find the difference. I have to subtract. As of right now, they don't have common denominators, so I can't subtract the numerators quite yet. But what I can do is, let's get those common denominators, and I think both of the denominators have an x already, which is kind of nice. The constants can change, though. I'm looking for a smallest number that 5 and 6 both go into evenly. All right, so let's see, I'm thinking probably a 30 would be my least common multiple. So I'm going to multiply this guy by a 6 over 6. And I'm going to multiply this one by 5 over 5. They both now have a denominator of 30x. Numerators, let's see, my 6 times 12 here and my 7 times 5 are going to be my new numerators. So my 6 times 12 gives me a 72, and my 7 times 5 gives me a 35. All right. And there was a big old subtraction in there. I only subtract the numerators. So I'm just going to do a 72 minus 35. So I get a 37 over the 30x. Now, if I can reduce this, I will. I don't think I can find anything that goes into 37 and 30, though. So this is as good as it's going to get. All right. Excuse me. Okay. So on to number 6. Rewrite the function g of x, this fractional function. They've got, let's see here. They want it in this other form. So there are basically 3 options. Option number 1, I could do the x under each of the parts of the numerator. I could do 2x divided by x plus 3 divided by x, which if I reduce it down, I get a 2 plus 3 over x. Okay, so that's one of my options. I should get the same answer if I do it a different way. And I think what we've been doing more than anything has been either the synthetic division or the long division. So let's see, if I use the synthetic division, so here's my option number 2, second way I could do this. Let's see, what makes this 0? Well, if I set the denominator equal to 0, I'll try to do all my synthetic division stuff over here in purple. So if I set the denominator equal to 0, it just says x equals 0. So the 0 goes in the box. I've got a 2x plus 3, so there's my 2 and my 3. I bring down the 2, multiply by what's in the box, which is 0, add straight down for a 3. So this turns into a 2 plus my remainder over the current divisor. The x is what I was dividing by. All right, so I actually get the same thing with synthetic division. And my other option could be long division. So if I do, let's see, my 2x plus 3 is divided by x. All right, x goes into 2x twice, so 2 times x is 2x. I'll go ahead and subtract those for 0. I bring down the positive 3, and I can stop there. This is a 2, and then I always put my remainder over divisor, so it's a 2 plus 3 over x. I get the same thing all these 3 different ways. So whichever one you're more comfortable with, go for it. I would say my preference would be to use this black one, the first one I did. If I was dividing by just a single number, that's when I would use this guy, because I was just dividing, it wasn't a single number, it was a single variable, but I only had one thing I was dividing by. So I think that's why I would do the black one in this case. The purple one, the synthetic division, I usually prefer to do the synthetic division if I'm dividing by an x without a coefficient. So if this was like a plain x plus 1 or a plain x minus 5 or something like that, but it was a plain x, I would go with my synthetic division personally. Again, obviously all 3 methods work, but that would be my preference. The last one, long division, I think if this had some other leading coefficient, if this was like a 3x, or maybe it's like even just a negative x, maybe plus 5, something like that. If there's some leading coefficient, I tend to use my long division in that case. All right, so I hope that helps. They have us writing our fraction first. They want the 3 over x first, and then the 2. Sure, that's fine. And to identify the graph, this is going to be helpful for all of the transformations. So like this plus 2 is shifting everything up 2. And I don't think anything was added or subtracted to my x, so I don't have any horizontal shifts. Like this guy's out. I didn't shift to the left or right at all. Same thing with this one. I didn't shift left or right at all. Out of the last 2, I was supposed to shift up 2. And you can tell the asymptote went up to this positive 2. The other one I went down to a negative 2. So no, that's out. I was supposed to go up 2. So here is my graph. All right. And then last one down here. How many units I was supposed to go 2 units up. That's why I chose the graph I chose. All right, and then number 7, find the difference. This one's kind of nice in that they already have common denominators, so I need to subtract the numerators. I'm going to do the x minus 4 over this 16x squared, and I'm done. That one's kind of nice. All right, number 8, find the least common multiple. We've talked about this before. I usually consider like the numbers separate from the variables. So let's see, I'm going to do GCF here. I'm going to factor it. So my GCF, greatest common factor, would be, let's see, an 8 and an x. So I'm left with an x minus 2. All right, I can see all its factors. Like I said, I'm going to consider constants first, so just the 24 and the 8. I think their least common multiple is probably 24. 8 times 3 is 24. Or I could have 24 times 1 is 24. So I think as far as the constant goes, my least common multiple is the 24. All right. For the x's, just plain x's, nothing added or subtracted. It looks like they each have at least a single x. This one over here actually has 2 of the x's multiplied together, hence the x squared. So I'm going to go with the x squared. And then x minus 2, I am missing an x minus 2 here. I need to add that in here as well. All right, so 24x squared. And I can kind of check and make sure that each of these would go in evenly. So like the 24x squared, okay, I've got the 24 and the x squared taken care of. All right, this guy, the 8x and the x minus 2, 24, I could treat this as like a 3 times 8. And my x, I can treat it like x times x. And then I have my x minus 2. So let's see. I've got the 8, I've got an x, and I've got the x minus 2 all in there. So yes, this actually is the least common multiple. All right, number 9. You have to find the sum. They do not have common denominators as of right now. So let's take a look at what the common denominator should be. As far as the constants go, I think the 3 and the 4, their least common multiple, I think, is just a 12. So I have to multiply by the 4 over 4 and the 3 over 3 here. So that'll give me a denominator as far as the number goes, constant. They'll both have a 12. For the variables, let's see, x squared, and this one's a plain x. I think I'm going to have to multiply by x over x to get that x squared. I already have an x squared on this one. So again, let's see, 4 times 3x squared is a 12x squared. Okay. 4x times 3x is also a 12x squared. Looking good. So I have common denominators. That was my goal. I still have to deal with the numerators though. So let's take a look at this. The numerator is 4 times 8. So my 4 times 8 is going to give me a 32. And then my other numerator, the 5 times 3x, so 15x. All right, and then when I add them, I will keep that 12x squared. I'm just going to add the numerators here, a 32 plus 15x. Now, is there anything that goes into 32 and 15? Let's see. 15, I can have a 3 or a 5 go in. I don't think either the 3 or the 5 goes into the 32. 1 and 15 go into 15. Neither of, well, I guess the 1 goes into 32, but it's not all that helpful. 15 doesn't go into 32, though. I think this is as good as it's going to get. All right. And then let's take a look at number 10. Rewrite this function in the form. So it's very similar to a previous problem that we did. And again, I'm going to refer back to those 3 methods because I have a plain x here. It's not even like a 2x or something. No coefficient, just a straight up x. One term that I'm dividing by. I think I'm going to go in personally with this method where I put that denominator under each of the terms in the numerator. So let's see, that gives me a 4x over x minus a 6 over x. These x's divide out, so I'm left with a 4 minus 6 over x. Okay, so they'll probably have you put the 6 over x. Oops. Okay, this is actually, let's talk about this for a sec. I was going to put the 6 over x first, but I was missing something. This 6 over x, and if I put the 4 here, what I'm missing is the fact that this was a minus right here. It's like a negative 6, so you got to put that negative. When you put the fraction first, I have to have a negative 6 over x first, and then the positive 4. Okay, so careful on that negative there. Let's see. To identify the graph, I think the 4 is shifting everything, and then this negative right here is a reflection, a vertical reflection, which means, let's see, let's go up 4. This one went down like 5. That one's out. This one went down 4. No. This one went up 5, but I need to go up 4. So I think I'm going to go with this guy, shifting up 4. Okay, so there's my graph, and I kind of already said we were going to translate 4 units up. Okay, so we already figured that one out. Let's see. Number 11 here. Find the difference. As far as difference, subtraction, all of my addition subtraction needs common denominators. So I got to do some factoring here. What multiplies by a negative 14 and adds up to a 5? So all of my options are either a 1 and a 14, a negative 1 and a negative 14. I'm listing stuff that multiplies to be 14. I know 2 times 7 is 14, negative 2 times negative 7, also a positive 14. And out of all of these, I think the ones, oh, it's supposed to be a negative 14. Oh my goodness, I'm off by a sign. Let me adjust this here real quick. Off by a sign. Let's see, if I'm going to be a negative 14, I have to have at least one of these numbers negative. Like a negative 1 and a positive 14, or a positive 1 and a negative 14. I can do a negative 2 and positive 7, positive 2 and negative 7. Okay, so I at least had to have one of those guys a negative number. And then the ones that add up to this middle term add up to 5. I'm thinking I'm going to go with the negative 2 and the 7 adds up to 5. Okay, so x squared not plus but minus 5 over my factored form. I'm going to put the x minus 2 and the x plus 7. My denominator here. All right, I've got x plus 3 over x plus 7. Okay, so I just kind of rewrote it in factored form. And then what this tells me is, okay, they both already have an x plus 7. I'm missing the x minus 2 on my second fraction. So I'm going to multiply by x minus 2 over x minus 2. So now they both have the x plus 7. They both have the x minus 2 in the denominator. So they actually have common denominators now. Good, that's what we're going for. Okay, so I'm going to put it all over that common denominator. All right, the numerator. Let's see here. My first numerator, x squared minus 5. Okay, careful on my subtraction here. I have to subtract all of this stuff, the entire second numerator. So I'm going to put minus, and I've got some parentheses around it. All right, this stuff I think I'm going to distribute. I'm going to do my x times x, so x squared. I got a negative 2x, a positive 3x. Oops, I have to move those parentheses, and then a 3 times negative 2 is negative 6. Okay, so at this point, I'm going to combine my like terms. Here, x squared minus 5 still, and I still have a negative on that whole polynomial. I'm just going to combine these like terms real quick. A negative 2 and positive 3 add up to a positive 1. Like x squared plus 1x minus 6. Denominator hasn't changed. Let's see, now I'm going to distribute my negative to each of them. That's why we made sure it was in parentheses. So x squared minus 5, that first part's still there. And then a negative x squared and a negative x and a positive 6. We distribute the negative to all those in the parentheses. All right, so now let's combine some like terms here. I got an x squared and a negative x squared. Okay, anything minus itself is 0. That's kind of nice. Plain x, I've only got one of those. Here's my negative x. My constants, I do have a couple of those. Negative 5 plus 6 is a positive 1. All right, and then my denominator. There we go. Let's go ahead and write this over here for our answer. Negative x plus 1, which I don't think that is a factor that I also have in the denominator. I can't really divide out any of those factors. So this is my final answer. Okay. Number 12, we have an equation now, an equation to solve. It specifically says by cross multiplying, so that's kind of nice. It's already one fraction equal to one fraction. So I'm going to cross multiply, get my negative 2 times the x plus 1, and then that's going to equal the other cross multiplying here, which is the x minus 1 times the x minus 8. Make sure you put the parentheses around the entire numerator and entire denominator as you multiply them. That means I've got to do some distributing. So that means I've got a negative 2x minus 2 equals, and then when I distribute here, I get an x squared minus 8x. I'll distribute my negative 1, so a negative x plus 8. All right, and I'm thinking because I've got a quadratic, I'm going to probably make it all equal to 0. So I'm going to like add this 2x on both sides. I'm going to add 2 on both sides. Okay, this is gone. I'm going to make it all equal 0. Move this down here. So 0 equals, I've got my x squared. I actually have a bunch of like terms right here. I've got a, let's see, a negative 8, a negative 1, so negative 9, and a positive 2. So negative 7x. And then let's see my constants. My 8 plus 2 is 10. All right. So the reason I want it all on the same side is so I can factor this guy and set my factors equal to 0. So let's see, multiplying to be 10 and adding up to -7. Let's see, 1 times 10, 2 times 5. Oh, I think a 2 and a 5 has to do with a 7. I think I'm going to make them both negative though. X minus 2 and x minus 5. Again, -2 times -5 is the positive 10, and -2 minus 5 is this -7. Okay, so that helps me find my x values. I get a 2, a positive 2 from that first factor, and a positive 5 from my second factor. The nice thing on these is, and I really suggest you guys plug it back into your original problem and see if both of those fractions actually do equal each other with a 2 and a 5. So let's see, there may have been an extraneous solution, so let's see if both of these work or not. Okay. So let's try our 2. So let's see, -2 divided by, and I'm doing a 2 minus 1. Notice I put the parentheses around the entire denominator. I had to divide by the entire 2 minus 1. All right, whatever that is, I don't really care what it is, but I do care that they both equal each other. So I'm going to check the 2 again. 2 minus 8, all in parentheses, divided by the entire 2 plus 1. Okay. Also a -2, so it's looking good for this 2. Check, that one is correct. Let's check out the 5. Okay, so in my first fraction, -2 divided by, and then I'm going to put in parentheses again, a 5 minus 1. All right. Messy little negative decimal, sure, whatever, as long as they both equal the same messy number. So the right side of my equation, again, I'm putting a 5 in for my x. So 5 minus 8 divided by a 5 plus 1. All right, also a -0.5, both the same messy decimal, so I don't really care what it is. I do care that they're both the same. That's also a solution. So let's see, are those listed here? They had a, here's my +2, and the +5 they also have listed. All right, there we go. All right, next up, using structure, identify the LCD, the least common denominator of the rational expression in this equation. So let's see. They have to have stuff in common. In fact, these two both have an x. So let's make sure we've got an x as one of our factors. So I think we kind of already took care of that. The only other factor I've got is the x minus 1. So I think x times x minus 1 takes care of all those factors in the denominators. Here's my least common denominator. All right, and solve for the equation for number 14 here. Let's solve this equation. I don't have, like I did in the previous one up here, I had a 1 fraction equal to 1 fraction, which is kind of nice. I could just start by cross multiplying. This one does not have a single fraction here. It's got 2 separate fractions. So I can't really just cross multiply right off the bat. I need to get that first stuff taken care of. I need 1 fraction equal to 1 fraction. So I think I'm going to treat this as a 3/1. None of these really have anything in common in their denominators, so I can pick any of these to combine. I'll probably just pick these smaller ones here, which means I'm going to multiply this 3 by x over x. So let's see, my 10 over x, I didn't mess with that, plus this is going to be a 3x over a 1x, or in other words, a 3x over x. All right, so the left side of the equation, they have common denominators now. That's good. My right side of the equation I haven't really messed with. So the left side of the equation, let's move this over here. If I actually add these, it'll still have the denominator of x. I just add the numerators, the 10 plus 3x. Okay, so it is now a single fraction, and the right side is also a single fraction, so I can go ahead and cross multiply. All right, so I get my 10 plus 3x in parentheses, like the entire numerator, multiplied by the entire denominator in parentheses. All right, equals, and then this other x times x plus 9, don't forget the parentheses. I got a bunch of distributing to do here. So let's see, I'm going to do my 10 times x, 10 times -4. All right, I'll distribute my 3x. I get a 3x squared and a -12x. All right. And then I've got some distributing on the other side as well. So I get an x squared plus 9x. Let's see. Again, I'm thinking I'm going to have to factor at some point. If I have to factor, I probably want it all equal to 0. So I think what I'm going to do is, let's see, if I put this in order, I'll put my highest exponent down to low, so 3x squared. My plain x's, I got some like terms here. 10 minus 12 is negative 2, so negative 2x. And then my constant is the negative 40. All right. Let's go ahead and subtract the x squared on both sides, and I will subtract a 9x on both sides as well. So I wanted that all equal to 0 for a reason. Let's see. I got a 3 minus 1, so a 2x squared. Negative 2 minus 9, so a negative 11x. And I still have the negative 40. All right. So I usually start factoring with a GCF. And let's see, so close, but 2 goes into, 2 and 40, but 11 is not divisible by 2. So for that reason, I think we're going to have to go with the factor by grouping. All right, so the factor by grouping is where I'll put this in another color, I multiply my first and last term. So 2 times negative 40 is negative 80. And I need to figure out what multiplies by negative 80 and adds up to this middle number here, negative 11. So let's see. I mean, 1 times negative 80, yeah, it equals a negative 80, but like when I add those up, it's negative 79. That's pretty far away from the negative 11. So let's keep it going here. Let's try to get some other numbers. 2 times negative 40, that adds up to what, negative 38, so still pretty far away. Let's see, 4 times a negative 20. Okay, that adds up to a negative 16. We're getting there. We're getting there. Okay, so let's see, what else can go evenly into my 80? I'm thinking 5 times 16. All right, one of them positive, one of them's negative. 5 times negative 16 is negative 80, and okay, 5 and negative 16 add up to a negative 11. Okay, so I think I'm going with this guy here, which means we are going to break our negative 11x, the middle term here, we're going to break it up into the 5 and the negative 16. So I'm going to turn it into a 5x minus 16x. And I haven't messed with the rest of it still. The 2x squared is still there. The minus 40 is still there. All equals 0. Okay, that stuff's all the same. The reason I did that is because now I can do a bunch of factor by grouping. So my first group, I think they have an x in common. I'm left with the 2x plus 5. My second group, I think they have an 8 goes into 16 and 40. In fact, I could factor out either a positive 8 or a negative 8. And I'm going to strategically factor out my negative 8 because negative 16 divided by negative 8 is a positive 2. So I get a positive 2x, and I want these guys to match. So I think that's why I'm factoring out a negative 8. I don't want to be off by a sign. And then my negative 40 divided by negative 8 is a positive 5. And again, these guys match. That's what I was going for. Good, good. So then I factor out the 2x plus 5. They have that in common. So it's still that GCF, that greatest common factor, comes out. And then my leftovers are the x minus 8. Okay, so if I set these each individually equal to 0, and I'm going to subtract my 5 on both sides, divide by 2 on both sides. Okay, I think that's one of my answers, and I'll add 8 on both sides, so I have positive 8. All right, so let's check this out and see if they both are actual solutions. I'm going to plug it into the original problem, negative 5 halves, which, let's see here. Okay, I'm going to erase that. My original problem is what I'm plugging it into. So as messy as this is, I'm just going to put it in the calculator. So 10 divided by my negative 5 halves, and I put it in parentheses for a reason. I'm dividing by the whole fraction, and then a plus 3. Okay, so that's the left side. And the right side, here's my parentheses for negative 5 halves plus 9, divided by the entire negative 5 halves minus 4. Okay, let's see, does that also equal -1? It does, nice, so the -5 works. My other answer was, let's see, that one, oops. This answer works. The 8, let's check and see if the 8 works. So I will do 10 divided by 8, and then plus 3. And then my other side of the equation, again, still in parentheses here, I've got an 8 plus 9 divided by my, in parentheses, 8 minus 4. All right, also a 4.25, nice. Okay, so not that the 4.25 is my answer. My answer was what I solved for over here. It was 8, and I checked it, so that works as well. So I had 2 solutions. There we go. All right, number 15, when can you solve a rational equation by cross multiplying? So let's see here. First option, when one side of the equation is a single rational expression. Or when one side of the equation is 0, when each side of the equation is a single rational expression, or when one side of the equation is a constant. Okay, so let's see what they're talking about as far as single rational expression goes. They talked about that twice. We know what 0 is. Constant, let's talk about what that is. Single rational expression. This means like one fraction. So these guys, a single, like one. Rational expression is a fraction. It's like one fraction. Constant has no variable. It's just a straight up number. 1, 2, 3, 4, 5, negatives, decimals, whatever, but no variable. So out of these, to solve a rational equation by cross multiplying, we always cross multiply when we have one fraction equal to one fraction. So let's see, do I want one fraction on only one side? No, I think I need one fraction equal to another one fraction. I need one fraction on each side. So I think I'm going with this guy. All right, and then 16. All right, we need to solve the equation, and in this case, I have to get one fraction equal to one fraction, which is pretty much what we were just talking about. And I think I'm going to start by factoring out an x in the denominator, because then I can look at the factors like, let's see, these both have an x minus 3, okay? These both have an x, all right. So, I mean, I might as well just stick with the left side of the equation, get them a common denominator. I'll do that by multiplying by x over x. So now I'm at my first fraction, minus, and then my second one multiplied by x over x. So I get a 6 times x over, and then if I distribute this, keep in mind this entire denominator, all of that is multiplied by x. So you can like put parentheses around it if you want to make sure it's all of that multiplied by x. So when I distribute my x, I get another x squared minus 3x because I want common denominators. So I can go ahead and combine those into a single fraction. All right, so I have 18 minus 6x in the numerator. All right, so step number 1, get one fraction equal to one fraction. So check, got that one. Then I've got to cross multiply. So let's see here. Okay, 5 times the entire x squared minus 3x, which equals, let's look at this guy. This is a x times the entire 18 minus 6x. All right. So I guess I'm distributing to do, I get a 5x squared minus 15x equals, now I distribute on this one, I get an 18x minus 6x squared. All right, let's see, let's put them all on the same side. I'm going to add 6x squared on both sides and subtract my 18x. Get a 0 here. This ends up with what, 11x squared, and we're at negative 33. All right. So I'm thinking, as far as factoring goes, I'm probably going to factor out an 11x. Their GCF, their greatest common factor. 11 goes into 11, and 11 goes into 33. Okay, so I factored out an 11. They both have x's, so I factored out an x, and it looks like I have an x minus 3 left. All right. So I didn't have to do factor by grouping or anything like that. I'm going to set my individual factors equal to 0. which if I divide by 11 on both sides here, I just get x equals 0. And if I add 3 on both sides here, I get x equals 3. So let's check these out and make sure. So I'm going to erase this because I want to use my original problem here. Okay. Let's see if our 0 works. Honestly, there's something I can see right off the bat, but we'll put it in the calculator just in case. So if I plug in a 0 for my x's, 0 squared minus 3 times 0. 0, there we go. So that's my first fraction, minus 6 over, and then I'm putting a 0 in, so 0 minus 3. Okay, so this is the left side of my equation. And, oh, error. It says divide by 0. Did I divide by 0? I think so, because when I plugged my 0 in, 0 minus 0 is still 0. This is making me divide by 0. So for that reason, this actually is not one of my solutions. Out. Let's try the 3. Okay, so I'm going to put 3. Oh, I see something again. I think we're going to get an error again. Let's check it out, though. Honestly, here's what I see in my head. If I'm plugging a 3 in, I'm going to get 3 minus 3. I'm going to be dividing by 0 again. So, I mean, if you guys want to put it in your calculator, go for it. But I think you're going to see this error problem again. Which, if I got an error on both, neither of them is a solution. So actually, interesting, I have no real solution. That's my final answer. All right, and then number 17 here. The student solves this equation and obtains the solutions 3 and 4. Are either of these extraneous solutions? Well, let's check. This is what we just did on the previous problem. We check our answers to see if they are extraneous solutions or not. So 3 and 4, let's try the 3 first. 4 divided by, oh, does this look like it'll have a problem? Oh, 4 divided by 3 minus 3 is 0. So yeah, there's an error here. So this is an extraneous solution. The 3 is. Let's try the 4, see if they both are. 4 divided by 4 minus 3. Okay, no error on that one. And then 4 divided by another 4 minus 3. Okay, I'm thinking these are equal to each other. Yeah, so the 4 actually was a solution. As far as the extraneous solutions, like extra, like it doesn't count. Only the 3 is an extraneous solution. All right. Number 18 here. Let's do some cross multiplying. All right, so I'm gonna have to distribute. My 2 gets distributed to the entire x squared minus 3 equals, and then when I multiply these, I need some parentheses. I need the entire x plus 2 times the entire x minus 3. All right, so once I distribute, I get a 2x squared minus 6 equals, let's see, x squared minus 3x, 2x minus 6, which I'm thinking I'm probably going to have to do some factoring again. I can combine some like terms here. I'll leave the left side alone for a sec. So 2x squared minus 6 equals x squared minus x, like my negative 3 plus 2 is negative 1. So there's my negative x there, minus 6. If I put them all on the same side, let's see here, I'll subtract my x squared. Let's see. Yeah, I'll subtract my x squared over for 1x squared. I'm actually going to add 6 on both sides, so like the 6's are gone. Nice. Here, I'll just. Alright, so my 6's are gone. I subtract an x squared on both sides. Okay, so I'm at a 1x squared. Still don't want x's on both sides, so I'm still going to add that x over. They are not like terms, so I cannot combine them. It's got to stay separate, x squared plus x. So what I got to do at this point is factor, and my GCF is x. Okay, I always start factoring with the GCF, greatest common factor. All right, so then I set each of these factors equal to 0. It looks like I get x equals 0, and x plus 1 equals 0. If I subtract 1 over, I get a negative 1. It looks like I could have 2 solutions, but you've seen a few previous problems where some of our solutions, if not all of them, didn't work. So let's check out the 0 and the negative 1 in our original problem. Okay, so the 0, I'm going to put the entire numerator, so the 0 squared minus 3 instead of my x squared minus 3. Okay, there's the entire numerator divided by the entire denominator. So again, when I say the entire thing, I mean I put parentheses around it. Okay, so that's the left side of my equation. The right side of the equation, I'm putting a 0 in for this as well. Okay, also equals a negative 1.5. Nice. Okay, so the 0 works. All right, there's one of my solutions. One, check. Let's try the negative one. Let's see if that one works or not. So again, in parentheses, careful here. If I enter it like this, I'm doing something wrong, you guys. The way I entered it was actually incorrect, even though I put the parentheses around it and everything. And the problem is with a negative being squared, the calculator needs me to show that it's not just this one that's squared, it's the entire negative one that's squared. So I need to put parentheses around my negative 1 also. So the entire negative 1 is all squared. And then minus 3. Okay, that's the numerator divided by the entire denominator. So it wasn't squared in this case. I don't need more parentheses. My negative 1 plus 2. Oh, shoot. Okay, hang on. So I'm wrong again. I was supposed to be dividing. Somehow I hit the minus sign. Okay, numerator divided by, there we go, my denominator. All right, so let's see if that negative 2 is the right side of the equation. So the entire x minus 3, which I'm plugging in negative 1 from x, so negative 1 minus 3, divided by 2, also equals negative 2. So they both did equal the same thing, which means this other one, negative 1, worked. That is a solution. So let's see, they have it in my list right here. There we go. All right, 19. Identify the LCD, the least common denominator, which I don't think any of these have anything in common, really. So I'm going to have to use them all individually. I'm going to have to use the 2 separate from the x plus 1, separate from the x plus 4. That is my least common denominator. All right, and then let's see, I think we got our last problem. We've got to solve by cross multiplying. All right, so do this again. A negative 1 times the x squared minus 27 equals, and then let's cross multiply these guys. So I'm going to get x minus 4 times x minus 3. All right, I've got some distributing to do. This one, when I distribute the negative, I basically change the sign on each of those. And here, I've got to distribute, I get x squared minus 3x. Distribute my negative 4, so I get a negative 4x plus 12. I do have some like terms here I can combine. Leave the left side the same for a sec here. Negative 3 and negative 4 combines to a negative 7, so negative 7x. All right, they both have x squared, so I'm thinking I'm going to have to put it all on the same side. I'm going to add my x squared on both sides, subtract 27 on both sides. So those are gone. I put the 0 on the right side this time. Sure, whatever. 0 equals, let's see, x squared plus x squared. In fact, a 1x squared plus a 1x squared, so a 2x squared. Negative 7x in the middle there. Got my 12 and my negative 27. All right, so 12 minus 27 for a negative 15. And then what multiplies? Oh, actually, I have a leading coefficient here. As far as GCF goes, greatest common factor, I don't think they really have anything in common, which means I can't get rid of that 2. So I've got to do some factor by grouping. So this is where I give myself some numbers that multiply to be, let's say 2 times negative 15 is a negative 30. What multiplies to be negative 30 and then adds up to negative 7? I could have 1 times negative 30, but that adds up to negative 29. It's a little too far away. Let's keep it going. 2 and a negative 15, they multiply to be negative 30, but they add up to, let's see, a negative 13. They're a little closer to negative 7, not there yet though. 3 and negative 10, those multiply to be negative 30. Okay, all right, and then 3 plus negative 10 is a negative 7. All right, so I think this is what I'm going with. which means I'm going to leave the first term, the 2x squared, I'm going to leave the same. It's still all equal to 0. My last one, the negative 15, is going to be the same. I'm just going to break apart my negative 7 into a positive 3x and a negative 2x. All right, and the whole point of factoring by grouping is so you can do a lot of GCF, greatest common factor. So the greatest common factor out of my first group, I think they both have an x in common. So 2x plus 3 is left, and I'm hoping on the next group, after I find their GCF, I'm hoping that what's in the parentheses is going to match this 2x plus 3. So let's see here. I can factor out of 10 and 15. Let's see, 5 goes into 10 and 15. If I take out a positive 5, I'm left with a negative 2x minus 3. But I want these to match. So I think instead of factoring out a positive 5, it's just off by a sign. I'm going to factor out a negative 5. So negative 10 divided by negative 5 is a positive 2. Here's my positive 2x. Negative 15 divided by negative 5 is a positive 3. Okay, so these actually match now. Good, that's what I was going for, because that's what they have in common. They have a 2x plus 3 in common. And that means, so that means I got rid of both of those. I am left with the x and the negative 5, so that's minus 5 is left. Okay, and still all my factors are equal to 0, so let's set the 2x plus 3 equals 0 and the x minus 5 equal to 0. And subtract 3 on both sides, divide by 2 on both sides. All right, here I got to add 5 on both sides. So it looks like I have two answers of 5 and negative 3 halves, which let's check though. All right, we've seen in the past that some of them didn't work, so let's see. Let's check the negative 3 halves. It looks like they're using a bunch of decimals. So let's see, negative 3 halves, if I want it in the decimal form, that would be like a negative 1.5. I mean, they're totally equal to each other. I just noticed that their answers are in decimal form. So maybe I'll check the negative 1.5. Okay, so the left side of the equation. Negative 1 divided by, and then in parentheses, I'm checking a negative 1.5. So I'll put that in for my x and minus 3. Okay, so that's the left side of my equation. Messy, sure. But all I care about is, are both sides of the equation equal to each other? So I'm going to put my negative 1.5 in for x again. All right, so it's like my x minus 4 all in parentheses divided by the entire denominator, which I have to have like parentheses inside of parentheses here. Whenever I raise a negative to an exponent, I have to have like the entire negative number all in parentheses before it's raised to that exponent. Okay, and then I've got my minus 27. All right, as messy as it is, they're the same. So yeah, the negative 1.5 works. So here's my negative 1.5. There's one of my answers. All right, check. That one worked. Let's try out our 5. So I'm going to put a 5 in here. Negative 1 divided by, and then the entire denominator, the entire 5 minus 3. All right, so I got a negative 0.5. The right side of the equation, again, put parentheses around the entire numerator and the entire denominator. All right, this one I actually don't need parentheses around 5 because it's not a negative. It's a positive 5. I can do that squared. It's just squaring the 5 and minus the 27, all in parentheses. Okay, those are also equal to each other. They both have the negative 0.5, good. So this one works. That was a 5. Where's that one on my list here? Oh, here we go. So there we go. We got 2 solutions. All right, I hope this helps you guys, and I'm sure I'll see you soon.